Why memory matters in agent systems. So if we talk about foundation models, like the large language models, so the foundation models, they are stateless. So foundation models, large language models, by default, they are stateless. So while they being incredibly smart, they are fundamentally static. So foundation models, definitely they are incredibly smart, but they are fundamentally static. That is, they don't grow or remember through experience unless we build a memory layer for them. So the foundation models, the large language models, on their own, they cannot store the information. They cannot remember through experiences. We have to have a separate memory layer for them. We have to bridge the foundation model. We have to connect the foundation model with an external memory system because foundation models are stateless by design. So if we talk about foundation models, the large language models, on their own, they cannot store information. They cannot hold information. They cannot remember. So they need a memory layer which will act like a bridge, which will connect the foundation model with the memory system. And now it is very much clear the importance of memory because foundation models, the large language model, the brain of agentic AI system, it does not have any memory. It cannot hold information on its own. And hence, memory plays a very important role in agentic AI systems because we will be needing an external memory system to store the experiences, the conversations. So, and we have to connect the memory system with the foundation model. Foundation models are context limited. Foundation models are context limited. So every foundation model, like every large language model, it has a context window. And what is a context window? Context window is a limit on how much text it can process at once. So the idea is that we give a large language model a input prompt. So the size of the input prompt, like how much text it can process at once, is the context window. So context window is basically the limit on how much text a foundation model, a large language model can process at once. So that is the context window. And definitely this context window is limited. It cannot be infinite. So usually the context window, it range, the size of it ranges from like 8K, 32K tokens, 8K tokens, 128K tokens. So that is the context window. So now it's very clear that if I talk about a large language model, at once, the text it can process, the number of tokens it can process is the context window. And now just imagine that you have something beyond the context window. Then what? So what happens beyond the window? To store that, I will be needing memory. So the solution is the integrated memory layer. So since the large language models, they have limited context window, their context is limited. So definitely the input prompt cannot hold all the information. I will be needing an external memory system to store the additional information, and I can just retrieve it and augment it with the input prompt. I can just retrieve the information from the external memory and append it with the input prompt and give it to the large language model. So because of the context limitation, limited context window of foundation models, it's very clear that memory matters in agent systems. If we talk about foundation models are forgetful across interactions. So since foundation models are stateless, they don't remember the previous conversations. So that's why they are forgetful across interactions. So for a large language model, each new session start fresh. Like every query you give to a LLM is a completely fresh query, completely new query, and it will lose the previous context. Because we know that large language model, it is stateless. It cannot store information on its own. It cannot store information on its own. Large language model cannot store the previous conversations. It is stateless. So every query is a new query, and it does not know anything about the past. So, and because of which we will be needing an external memory to store the interactions. Because the foundation models, the large language models, since they are forgetful across interactions, wherein every interaction is a fresh interaction, there is no continuity between sessions. So for foundation models, they are forgetful across interactions, so no continuity between sessions. So we will be needing an external memory system which will be acting like a integrated memory layer. So the model will be interacting with the memory system to maintain the continuity, to remember the previous conversations. So now it's very clear that if we talk about foundation models, they are stateless on their own. They cannot store information. They cannot remember the conversations, their responses. They are forgetful across interactions. Every query is a fresh query. And foundation models, they have a limit on the context window. They have a limit on the context window. So looking at all these, it's very much clear that there is a need for integrated memory layer in agent systems, because this integrated memory layer in agentic AI systems, it will enable continuous learning, because we will be storing the responses in the memory. And let us suppose the interaction, if we are storing in memory, it is sort of a learning, the real time learning. Because large language model, whatever it knows, the pre-trained, the knowledge it has got, it is there. Along with that, it will also be having access to the live knowledge in terms of the memory. So while generating the response, it will be making use of its previous knowledge, the stored knowledge, along with the knowledge stored in the memory. So integrated memory layer, it enables continuous learning. It enables extended context, personalized interaction, and long-term coherence. And definitely, integrated memory layer is very important. It is essential. It's not just important, it is essential for true agent behavior. So just imagine an agentic AI system without memory. So without memory, an agentic AI system, in an agentic AI system, there will be no personalization, because without memory, this system will not remember the interactions. It will not store important information. So there will be no personalization. There will be no continuity for because every query to the large language model will be a fresh query. So without memory, agent systems will lead to repeated questions. It will keep on asking same questions again and again to clear its confusions. And because of that, we will have poor user experience. So now it's very clear that without memory, agentic AI systems will have a poor user experience, because there will be no personalization, there will be no continuity, and the agentic AI system will keep on asking the same questions in every interaction, because every interaction will be a fresh interaction without memory. Because large language model by default, they are stateless. They cannot remember the conversations. They cannot store information. They are stateless. So if we talk about agentic AI systems with memory, so with memory, in agentic AI systems, we have context aware conversations. So if agents use external memory like the vector database to store vast amount of data, then definitely instead of trying to read everything at once, instead of trying read everything at once, the agent performs a lookup to retrieve only the relevant snippets from the vector database needed for the current task. And this is what is called as context aware conversations. So in context aware conversations, the idea is that the agent will make use of an external memory like a vector database. That vector database will be storing the vast amount of data. So instead of giving that vast amount of data as an input prompt, as a context window to the large language model, we are storing that vast amount of data in a external memory like the vector database. And based on the query given to the large language model, we will be only retrieving the relevant chunks based on the query. The relevant chunks, we are augmenting it with the input query and giving it to the large language model. And because of that, the query, the quality of the input query will enhance because we are giving more context to the input query. And this is what is context aware conversation is. And automatically, since the quality of input prompt has improved because of the enhanced context, the response will be much better, much more clear. So that's the idea. So now it's very clear that with memory in agent systems, with external memory in agent systems, we can have context aware conversations in agentic AI applications. With memory in agent systems, the agentic AI systems can have personalized behavior. We can have personalized behavior in agentic AI systems. So true intelligence involves adapting to a user's preferences over time. So the idea is that when the agentic AI system is interacting with the user, it will learn many new things about the user. Like it will learn the user preferences. And if we are making use of an external memory to store the user preferences, so the large language model will make use of those user preferences in order to generate responses. So the memory, it allows an agent to move from reactive. Reactive means just answering questions. So memory allows an agent to move from reactive to proactive. Proactive means anticipating needs. And how it will be proactive? Because it knows the user preferences and the it will be able to anticipate. For example, with memory, the agentic AI system will be able to remember the coding style and tone. It will store the coding style and the tone of a particular user in the memory. So it will remember your preferred coding style or tone of voice. It will be knowing that the meeting always refers to the Monday 9 a.m. sync because of the user preferences, the stored user preferences in the memory. And it will, the agentic AI application, agentic AI systems, it will also be able to recall past mistakes to avoid repeating them. So now it's very clear that with memory in agentic AI systems, we can have personalized behavior. So true intelligence is adapting to user preferences. So the idea is that with memory in place, we will be able to get the user preferences and store it. And with the user preferences in place, our agentic AI system, it will become proactive. From reactive, it will transform into proactive because reactive means just answering the questions, but proactive means anticipating the need of the user. So we can store the user preferences like the coding style, the tone of voice. With memory, agentic AI systems can perform multi-step task tracking. Multi-step task tracking. So see, if we talk about task, complex task, we have to break it into subtasks. So complex task, it needs distinct steps. For example, if the task is plan 3-day trip. So to plan the 3-day trip, I have to break it into steps. So step one will be to find the flights. Step two will be to book hotel. Like that, step three, step four. So any complex task, if we take, we have to break it into multiple steps. So that is what multi-step task is. So a complex task, if we break it into multiple steps, so that is what multi-step task is. Now, without memory, what happens is that an agent might finish step one, like finding flights, but forget the specific flight times when it moves to step two. Because just imagine if memory is not there, the output of step one, it will not be able to store. And because of that, the step two will suffer because step two might have a connection to the step one. Because step one, find flight, if I find the flight, I know the timing, the arrival timing, and I will book hotel accordingly. So booking hotel, step two is connected with step one. Step two is dependent on the response of step one. And if I am not storing the response of step one because of lack of memory, then this multi-step task tracking is not possible. So without memory, multi-step task tracking is not possible. So we need memory. We need memory because with memory, we can very easily store the outcome of every step and we can make use of those outcomes in the next steps. So with memory, for example, if we are making a short-term memory, if we are making use of a short-term memory, then what happens is that the outcome of the step one, like whatever flight we have chosen, the details of that, like the flight times and the sub goals, like hotel near airport. So that we will store in the memory. And in the step two, while booking hotel, we will be making use of these information because to book hotel, I will be needing the location. So location will be near the airport and the timing. So memory enables multi-step task tracking. So it's very clear that with memory, we can have multi-step task tracking in agentic AI systems. And similarly, the outcome of the step two, we can store it in the memory and step three can make use of it. Like that, we can keep on doing. So multi-step task tracking is possible with memory. So with memory, agentic AI systems, they can learn from past interactions. With memory in place, agentic AI systems can learn from past interactions. So if we talk about reactive systems, so reactive systems, they just respond to the last thing said, like a calculator. So reactive system, they don't have a long-term memory. So they will just remember the last thing said. Like the very good example of it is calculator, because in calculator, it can store only up to a very limited extent. It can just remember the last thing said. It's a reactive system. But if we talk about contextual agents, like they should support context aware conversations. For example, and contextual agents, the response is based on the cumulative history of who you are and what you have done. So this is very important. So now it's very clear that if we talk about agentic AI systems, agentic AI system, we want it to remember who we are, who the user is, and what all interaction we have done. So the response should be based on the cumulative history and not just the last thing said. So agentic AI system, in agentic AI system, it should be contextual. It should, the conversation should be context aware, and we can achieve that with memory. So now it's very clear that with memory, if we make use of memory in agentic AI system, then definitely our agentic AI system will become context aware, wherein the response will not be reactive, rather the response will be based on the cumulative history. Like, response will consider who you are, what you have done. So the quality of response will be much better, much more accurate. So memory in agent systems, it transforms the agents from reactive to contextual systems. See, the memory, it transforms agents from reactive to contextual systems, because now the response of an agentic AI system will make use of the cumulative history. It will make use of the context. So now we are realizing the importance of memory in agent systems. So memory is the glue that turns an isolated AI model into a functional, reliable partner. Because we know that AI model, the large language model, the foundation model, it is stateless. It cannot hold information. It cannot store information. So memory will act like a glue, wherein external memory, we can store information in it, and the large language model can make use of that information. So memory is the glue that turns an isolated AI model into a functional, reliable partner. So memory is the difference between a tool and a teammate. Memory provides the continuity required for trust, efficiency, and sophisticated problem solving. See, the idea is that if we make use of memory in agent systems, definitely the trust will be built, because with memory, the agentic AI system will remember your preferences. It will remember like what things you don't like, what you like, and the responses will take care of that. Like, let us suppose you have allergy to something, and if agentic AI system knows that you have told it, then while recommending you some recipes or what to eat, it will remember, and hence automatically my trust will build. So memory, with memory, there will be trust, there will be efficiency, and we will be able to do the sophisticated problem solving, like the multi-step task tracking we will be able to do. Like a complex task, we can break it into multiple steps. The outcome of every step, we can store it in the memory, and the next step can make use of the previous outcome. And in this way, very complex task we will be able to accomplish. So sophisticated problem solving we can do with memory in agent systems. So now it's very clear the importance of memory in agent systems.